Thanks, Elaine. Unfortunately, Nathaniel, my co-presenter, can't make it today because of family obligations, so you're stuck with me. I think I have 13 minutes to tell you about rebuilding Earth, so I'm going to go through this very quickly. Last year at Oklahoma City, we discussed how we built natural Earth originally. It was kind of a hodgepodge, piecemeal endeavor, not according to a big master plan. We felt that it was a bit inaccurate and that we would need to rebuild it from scratch. And I guess I have to say, be careful what you volunteer to do. It's turned out to be quite a big job. We started off with coastlines and then built up through all the other vector layers. And this is the status to date. We have coastlines done, glaciers and ice shelves, admin 0. When I say done, it's in a draft form. These things are always going to be updated. All the pieces have to fit together. As you add new coverages, things will change a little bit. In addition to those layers, we have populated places that are now underway, and also rivers and lakes, which is the really big problem that we're going to be dealing with, and I'll be talking about later. So let's jump into coastlines. You've already heard a lot about coastlines from Nat. On the top, you see the existing natural Earth coastline. It's pretty good. The new one is slightly more detailed and an awful lot more accurate. It primarily derives from world vector shoreline, global prototype shoreline, and it's referenced to various raster images, including satellite imagery, so it's a lot more accurate. We think that the new scale of this data set is closer to 1 to 7.5 million rather than 1 to 10 million. And Nat also talked a little bit about estuaries, the problem there. Where does a river end and an estuary begin? The new natural Earth coastline is a little more conservative with estuaries, as you can see up there at the top. Also, it's more conservative with coastal lagoons. There's a lot of those with sand spits at the entrances, with very small inlets that are almost imperceptible. We're tending to show those more as lakes on the new data set, for better or for worse. Okay, the coastline has an awful lot of really tiny islands. That's not a big problem, except for in nearshore areas like Island off of Finland and Sweden that Nat showed earlier. Here we see Cuba. All these small islands create a little bit of visual noise. So we're filtering out the small islands in nearshore areas, such as that. However, an island of similar size, that's very small, out in mid-ocean is retained because it's out in the middle of the ocean, it's small, it's isolated, it's more important than some of these smaller keys off of Cuba. Then there's Antarctica, arguably the most changeable coastline in the world when you deal with Antarctic ice shelves. We're using U.S. National Ice Center data. Thank you, Mark Daniil, if you're out in the audience. He told me about this a couple months ago. Wonderful new data set that just came out a couple months ago. And let's compare that to some of the other Antarctic ice shelf data sets that are out there. You can see off to the right, there's the Conger ice shelf. This is East Antarctica. It disappeared in March of this year. And so this new data set actually captures that disappearing ice shelf there. Another problem with Antarctica is the ice shelf, but on the landward side. It's the so-called grounding line. It's buried under a couple hundred meters of glacial ice. Where exactly is that land-water interface? And we spent a lot of time trying to get that line defined as closely as possible. Let's go off to glaciers. With the glaciers, I did a lot of digitizing, and mind you, I did a lot of digitizing on all of this because it has to be in the public domain. I had to create new data. We don't want you to have to attribute natural Earth. Here's the digitized glaciers of the southern Andes, mostly using GLIMS and the Randolph Glacier Inventory as references, plus lots of raster land cover data and satellite imagery. One of the things that we were very careful about are glaciers that go down to tidewater, or in this case into Lake Argentino. We wanted to show that the Perito Moreno glacier was bisecting the lake, and there's a photo of it. It's actually a pretty stable glacier and is still bisecting that arm of the lake. Then in Central Asia, Karakoram Range, one of the things that's happening worldwide, as you know, glaciers are retreating, and of course streams emanate from the snouts of glaciers. So what we've had to do with the stream coverage is to extend the streams upslope, 5, 10, 20 kilometers to actually meet the snouts of glaciers. And then look at K2, look at the photo. Probably half of the area that you see is non-glacier, but look at the glacier coverage on the map. The glaciers are pretty generalized. We're not showing every area of rock, so just be aware of that. I kind of look at this as being a glaciated area rather than a strict glacier coverage. Rivers and lakes. Okay, this is the big problem that we've been dealing with. There really isn't good public domain river data available, and I'll go through how we're working on that. First of all, we're not alone in doing this. Heather, Mary, Corwin, and Alex have been volunteers working on this. Thank you very much, you guys. You've been indispensable in this project. And look at this, we're making pretty good progress. The world map is starting to get filled up with color. You'll note that North America is the last area that we're dealing with. I didn't want to start on a familiar area. I wanted to go to some of the more difficult areas, and that's worked out pretty well. By the way, Antarctica was the easiest continent to do for obvious reasons. Okay, let's look at some of the rivers. Here's the existing natural earth data, 1 to 10 million. Here's the new 7.5 million data. Not only is it more detailed, it's more accurate, and there's just a greater coverage of rivers. Well, let's look at this little tributary. I'm going to walk you through how we mapped this particular tributary somewhere on the island of Madagascar. What we used for selecting rivers was the National Geographic Database 1.0. Alex Tate kindly gave us a very downsampled version of that as just kind of a rough guide of, what rivers do we need to pick out to use. So you can see the National Geographic River there, and of course we're looking at all different reference sources in doing this. Here's hydrosheds. The alignment's a little bit different. Things are, the National Geographic data was kind of roughly positioned. Hydrosheds is great. This is Strahler Streamwater 6, but look, it's taking a right-hand turn up another tributary. So National Geographic has a slightly different idea of where this primary river goes. And of course, hydrosheds does not have names, data assigned to it. So another resource that I've been using is the 1964 Soviet Atlas Mira. It's very generalized, but it shows rivers fairly well, and there are names. A lot of the names have since changed, but it kind of gives me an idea of what rivers are where. And then their Cold War adversaries, the US Army. Here's a 1 to a million ONC map. You really can't read this at this zoomed out size, but if you zoom in, you could see the same rivers there. This identifies the two rivers as the Mahajilo and the Sake River. That was more clues about what those rivers were named. I then downloaded names from the National Geospatial Agency Geographic Names server. This is kind of odd. Rivers are identified by dots, so linear features identified by dots at their mouth. Brooke is nodding her head in approval. This is US government data. This is really good stuff. This further confirms that those two rivers that I want to map are the Mahajilo and the Sake River. Great, we're moving ahead here. I'm looking at all different sources. Mind you, geographic information can't be copyrighted. So I can look at these things and say, just to confirm what things are. And again, the river names are in agreement here. It's like, woohoo, this is really good. Now I can start thinking about digitizing the river in. So I'm grabbing all kinds of imagery, Google, Bing, Esri imagery, zooming in and tracing the lines and digitizing it. So it's a lot of work. And after the lines are digitized, I will attribute the names and other information. And as a sort of a last sort of sanity check, I would create a shaded relief from 90-meter SRTM data. We can't have rivers, of course, flowing through mountains. This is a shaded relief created with Bernie's Edward software, nice and clean and sharp. And there it is, those two rivers. And then I would move on and do the next river, and the next river, and the next river, eventually finishing Madagascar, finishing Africa, and then the world. Oh, it's like putting together a jigsaw puzzle with tens of thousands of pieces, plus attributes. Let's talk about them. Feature classes. These feature classes will look familiar to you if you're using natural earth, rivers, intermittent rivers, canals. We have a few of those, like central lines if you want to remove the reservoirs to make a historical map. For intermittent rivers, I'm usually relying on atlases and older map sheets for that information. Then there's the permanent lakes that we show. Lakes, reservoirs, alkaline lakes, and I'm thinking about maybe having a category for lagoons. That's still up in the air. A fair amount of research has to go into what is an alkaline lake, and if it's an endoheric basin, a closed basin, the chances are it's alkaline, but you still have to do some Google searches and show that for sure. But it's the impermanent features that are really just giving me fits. In general, for lakes and rivers, arid areas take 2 or 3 times as long as well-watered areas on Earth to map. Look at all these different categories of things you find in arid areas. Some are filled up most of the time. Some of them aren't. Some of them only have an inch or two of water after a very, very, very heavy rain. How do you map these? How do you classify these things? And at this point in time, I'm just thinking about grouping them into this, lumping them all together as intermittent or dry lakes and just leaving it at that, at least for now. So I'm going to be wrapping things up right now. I just want to, just again give a big shout out to the lakes and river volunteers. Also, Leo Dillon has volunteered to redo all the populated places for Natural Earth. Thank you very much. There's also some interesting side research that's happening out of this project. Bernie Yenny and Dilpreet Singh, one of his students, are using machine learning for filtering out nearshore islands versus oceanic islands. That's looking very promising. And then there's also a side project with another one of Bernie's students, Bridget Walker and Tim Samsonov at Moscow State University, about creating hypsography. And for small-scale maps, generalizing contour lines is a lot more difficult than you think, and they're working on solutions to that particular problem. Now, I'm going to end at this point in time and say we have preliminary data at this 1 to 7.5 million scale available today at this URL. The data is available for Africa, South America, and Australia and New Zealand. Go ahead, download it. It's in shapefile format. Also, there's Adobe Illustrator maps with map publisher georeferencing. Please take a look at it. The more eyes that look at it, the better. Report any problems that you see, and we will fix any of those problems that are in the data. So, and with that, I just want to say one more thing. We're looking for volunteers. So if any of you, have a couple hundred hours to spare, no, you don't need that many, please let us know, and we'd love to get you on the team. Thank you very much.